Right, so here's just my simple example. I just made up these numbers just so I can get gradient 1, gradient 2. You can see that it really doesn't matter what your y-intercept is. It doesn't factor at all into the way you're going to get your solution here, okay? Because you can move them up or down wherever and the angle will remain the same, okay? So let's start off by saying you can actually just quote this result. Tan theta, that angle between the two lines, is going to be equal to, now, think in terms of your tan expansion as you go through these numbers, okay? I'm going to put this gradient, which is gradient 2, and this gradient, which is gradient 1. I'm going to put them in that order, okay? So I'm going to go m1 minus m2 divided by 1 plus the product of those, okay? So that gives me 1 over 3 for tan theta. All right, grab your calculator out. This topic, confusingly, is generally done in degrees, so make sure you're in the correct mode. Okay, so I'm not interested in the accuracy so much, I just want to get the general thing so we can see what's going on. To the nearest degree, I'm getting 18 degrees. Okay, is that checking out? You guys getting the same thing? Yes? Yeah. No? I haven't even got my calculator out. Yep, okay, great. No worries. So 18 degrees. Now, does that look about right? That looks okay, right? I mean, I know my diagram's not perfect, but it does look like it's in the ballpark, okay? Now, let's just consider for a second, what would have happened if I did the order the other way around, right? If I swapped them around and did instead 1 minus 2 over 1 plus 2, well, I guess it should be 1 times 2. What difference would it make? Well, you can see, because in the denominator you got m1, m2, okay? So multiplication, it doesn't matter what order you put things in. So my denominator will still be 3, okay? So no change there. But on the numerator, the only difference is as we switch them around, I've now turned it negative, okay? Now because tan is it's an odd function, right? So when you slap in tan inverse, both sides, you get theta is equal to minus 18. Okay, now, grab a sheet, that's okay. Now you tell me, this minus 18, what does it mean? It's wrong. That is one way to think about it. Okay, all right. Now, it's a bit unclear for now. Think about it this way. This theta that we're after, right? I'm not trying to solve an equation. I'm trying to measure an angle. When you're measuring things like measuring a length or measuring a time or that kind of thing, measurements should be positive, right? So actually, theta equals minus 18 doesn't really make sense. So how do I get it into the domain? Well, what is the domain for theta? Now, yeah, that's right. I mean, you can see, right? The domain here is actually from 0 to 180, okay? I couldn't have a reflex angle between the two lines because then there'd be a negative angle between them. That wouldn't make sense, okay? So how do I get from this, what is this related angle for between 0 and 180? I've got to add 180, don't I? So instead of minus 18, I really should say 162, right? Does that make sense? Okay, so what have I worked out? I've worked out the other angle, the obtuse angle. Okay, now you remember I said before, when you get questions like this, 95% of the time, they will say, work out the acute angle, okay? So if we want to work out the acute angle, what order should you put the gradients in? Think about it. Yeah, exactly. All I want is for the tan value to be positive. Okay, so if I've got 2 and 1, I'll put 2 first because it's bigger. That's going to give me a positive value at the end. Okay, yeah. Shouldn't I absolute value? Yeah. I'm going to discourage the use of absolute value because it kind of strips away like what does it mean? What does it actually tell you? And also for the 5% of times where you're looking for the obtuse angle, right? Absolute value will not help you, right? You've actually got to add 180 instead.
You can 180 minus whatever you get.
So, here's what I'm going to recommend. Okay, here's what I'm going to recommend. They're going to give you 2 lines and say, work out, for instance, work out the acute angle. Okay? So in that case, if you know you're after the acute angle, just put the bigger one first, and then subtract the smaller one. That's all. Big minus small if what you're after is an acute angle between the two lines. Okay? Now, that's not always what they're going to ask you. Okay? For instance, sorry, this is what I'm after. Actually, I won't rub off the whole thing. For instance, sometimes they will say, here's two lines. Okay, they'll give you a third one, like say, oh, I don't know, something like that. Okay, with a third gradient. And then instead what they'll ask is, okay, tell me what the angles are within the triangle that they form. Okay, so they'll say, look, whoops, there's 1, 2, 3 angles. Okay, now in this case, or in all cases, you know, 2 of them will be acute. They might all be acute, but one might be obtuse, as it is in this case. Okay, so therefore, when you've drawn it out, then you'll know which one you're going to go for, and which one you should say, okay, I'm going to add 180 to that, because clearly it looks obtuse. Okay. So, if they're not just asking for an acute angle, you really ought to say, the safest option is, just draw a rough sketch, okay? Because otherwise, like, even if I knew what these values all were, I don't know, feel like me, I'm not intuitive enough to know which ones are going to be acute and which ones are going to be obtuse like, right away. I need to have like a rough sketch there, okay? And remember, they're not marking your sketch, it's just your tool to work out which ones are going to be acute and which ones are obtuse. That's all.